Hey! In this video, you're going to see how to crack a really elegant exponential problem, one that looks intimidating at first, but hides a beautiful trick inside it. Here's the problem. We have 16 raised to the power of x squared plus y plus 16 raised to the power of y squared plus x, and this whole thing equals 1. Our job is to find the values of x and y that make this true. Let's simplify things with a clever substitution. We'll call the first exponent a, so a equals x squared plus y, and we'll call the second exponent b, so b equals y squared plus x. Now here's an important observation. If we think about the graph of 16 raised to some exponent, the smallest that exponent can be while the whole expression still makes sense. Well, at that boundary point, the function's value is exactly 1. This tells us something powerful. Both a and b must behave in a very specific way. That's our first big clue. Next, we bring in a classic tool from algebra, the arithmetic mean, geometric mean inequality, often just called the AMGM inequality. Applied here, it tells us that 16 to the power of a plus 16 to the power of b divided by 2 is always greater than or equal to the square root of 16 to the power of a times 16 to the power of b. When we substitute the value of 1 into this expression and simplify things with a little algebra, we find that the average of 16 to the power of a and b, that is less than or equal to 1/2. And here's the clever part. If we plug in the negative of 1/4, we get an answer of 1/2. This means the average of a and b is less than or equal to negative of 1/4, which also tells us that a plus b is less than or equal to negative 1/2. Now, we put back the original values of a and b, written in terms of x and y. When we do that, we get an expression on screen that, if we rewrite it, takes the form of a perfect square. We're getting much closer now. What we end up with is the quantity of x minus 1/2 squared plus the quantity of y minus 1/2 squared is less than or equal to 0. But here's the beautiful part. Since any squared number is always greater than or equal to 0, having two squared terms add up to something less than or equal to 0 forces this inequality to actually become an equality. There's no other way around it. This means each squared term individually has to equal 0, so x minus 1/2 squared equals 0 and y minus 1/2 squared equals 0, and that means x has to be 1/2 and y also has to be 1/2. And just like that, that solves our problem completely. What looked like a messy exponential equation turns out to have one clean, elegant answer, hiding behind a smart substitution and a classic inequality. Please like, share, and subscribe for more content just like this. See you in the next one.